So we are discussing the dq function in the circular queue. So in case of a dq, that is dq means to delete an item from the queue. So we have to first of all take the underflow condition. So in the underflow condition, there are some conditions. So first of all, when it is initially empty, then the underflow we cannot delete anything. So when it is initially empty, we we can know when front equals to -1, because as soon as we entered we enqueue an element, we make the front as 0. So this is when one item is added or one element is added. Initially the front is -1. So our dq in the dq operation, when the first front is -1, then there is a underflow. That is, initially when the queue is empty, we cannot delete. Else, if front equals to rear, so when the front will become equals to rear, now let us see. Suppose now here initially the front is -1 and my rear is also -1. So now suppose I add one more element. Say one element, the first element I add 10. So the front is increased because when it is -1, when we enqueue, it becomes 0. We make it 0. The rear is automatically incremented in enqueue 1, so it becomes also 0. Now suppose we add one more element. Now let us take 20. So here the rear value becomes 1. 0 plus 1, that is 1. When we add one more element, say 30, then also it add one more element, rear becomes 2. One more element, rear becomes 3. Add one more element, the rear becomes, now 3 plus 1, it becomes 4. 3 plus 1, it becomes 4. Now rear is 4. Suppose now I keep deleting 10. I deleted 10. Now the front has to be increased. Now it becomes 1. I deleted 20. The front has to be increased by 1. It becomes 2. I deleted 30. Now the front is increased by 1, that is 3. I deleted 40. Now the front is increased by 1. It becomes 4. Now if you see, the front is 4 and the rear is 4, and we still have how many elements? We have one element, 50. So now in the dq operation, we will always find that front when when front equals to rear, then there is only one element in the queue. So what we do in that case, we will initialize, or we will make the front value to -1 and rear value again to -1 in the dq, because that element is now removed. We have to remove that, and we will reach the initial condition before we started in the circular queue, that is front is with front -1 and rear -1, and that we have done in our program, that is front -1 and rear -1. Else we will print the item to be removed and we will increment the front as per the circular queue notation by using the remainder or mod operator. Now we'll go to display. In the display, what we will do is we will print the elements in a loop starting from front to rear plus 1, and since it is a circular and we are using mod, and we should not cross the number of elements or the index. So we will use this I is equal to I plus 1 mod n. We will be incrementing till rear plus 1 from front. So now let us see, now let us run the program and see the output. Now say I enter the operation 1 for NQ. Enter the item we want to insert. Say I enter 12. I want to perform more operations. Yes. Say I enter one more element. Say 23. I enter one more element. Say 33. I want to perform more operation. Yes. Suppose I entered one more element. Say 45. I entered one more element. Say 56. And now I want to see the total elements in the queue. So now it went in a loop because here we have not because no, I think we'll run it again. Let us see. We'll run it again. Say, and we will enter the elements 1. Say 1, and we'll enter one more. Say 2, 3, one more, 3, 4, and one more. Say 56. And suppose I want to see these elements. Now it is 12, 23, 56. Suppose I add one more. Say I entered 34. I entered 44. Now I want to see the display. So I'll use 3, and it is going in a infinite loop. So before we know why it is going in an infinite loop, we will see that it is printing from 0 to 4, and where our front is 0 and rear is 4, so 0 and I is not equals to 5, that is from 0 it will go to 5, and it will increment I is equal to I plus 1 mod n. So, and n is 5 here, so it will never reach 5. So in that case, if we make this one, since this is never equals to 5, so it will go on, so we'll have to make it rear. Now if we run this program, again 1,